Hey everyone, how's it going? Professor Bryant back with another installment of Workout Wednesdays here at Light Atom Technology. Today's content is going to be covering electronic configuration, but more specifically, electronic configuration of ions. Remembering that ions can either be positively or negatively charged, meaning that they either have more protons than electrons or less protons than electrons. And this can be represented mathematically utilizing a very basic premise of integer value number of protons minus an integer value number of electrons. And that will be whole numbers: 3 minus 1, 3 minus 2, 5 minus 6, etc. Now, any atom with a charge will have a listed symbol as a subscript, and you can see that here in the example that I have written here for lithium. Recognizing that lithium, being in its second period, having 3 protons, if it was to in fact lose an electron, we would only have 2 electrons, and it would in fact have a positive charge. So let's look at a few examples of this. If we take a look at nitrogen, nitrogen being in the second period with an atomic number of 7, we expect nitrogen to have 7 total protons. And if we look at number of protons minus 10, that is the only way that we can get a -3 and show us the negative charge of the nitride ion. Okay, nitride. And that's a nomenclature we'll go over later. If this 10 is the number we need, then 10 is the total number of electrons. And we must create the electronic configuration based upon the total number of electrons and place them in the orbitals the same way that we have done in learning about the ground state electron configurations. Electrons need to go in separate orbitals until all of them are full, and then pair them with opposite spins if we were talking the orbital energy diagram. But in this case, we are just being asked to write out the basic electronic configuration, which will be 1s2, 2s2, 2p6 to give us a total of 10 electrons. And if we look at our periodic table, we will find that 10 total electrons will give us the electronic configuration for the noble gas of neon. If we do the same for magnesium, a alkali earth metal in the third period second group with an atomic number of 12, to get a +2 charge, we would need to lose 10 electrons. Lose 2 electrons, which would give us a positively charged. Okay. The total number of electrons would only be 10 for us to get that charge of +2. Now notice in each scenario of these 2 separate elements that we have created ions with, we have a total of 10 electrons, and we find ourselves with the exact same electron configuration. Now, are these the same element? No. However, again, showing that we have the exact same electron configuration here because we have 10 total electrons for each. Now, are these the same? No. Electronically, they are the same. And if we are paying attention to what is occurring to these atoms electronically, they are moving towards group 8, or they are moving electronically towards the noble gases because they both have a noble gas configuration. When 2 elements are said to have the same number of electrons and the same electron configuration, we call them isoelectronic, meaning these 2 ions have the same E config. And this is how you would approach electronic configuration of ions. You're either adding or subtracting electrons, excuse me, from the total number of electrons in the ground state. All right, if you have any more questions, feel free to send me an email.